recording. So I think you can see my screen, right? I'm going to Wokwi, Arduino. I'll try to do the same circuit we did last class, just to solve the challenge first. So here I'll add a breadboard, just half. I'll add, oh, not this button, a small button, and I need to rotate this button so I can use it. Okay, I will attach it here. Cool. I don't remember which pin I was using last class, but I will use any. Okay, 5 volts. Then I'll add a resistor. Then the GND, the ground. Okay, the ground again, and here the pin to the button. Okay, just change color here. Done. Now I will add a LED. I'll place this LED here. One more resistor. This resistor can be 100 ohms. Done. Then I will attach pin 12 here and the ground here and the slack. So just to remember, let's do same thing again, and after that I'll add one more LED. So here we have int red equals to 12. Then inside the setup, I'll initialize the serial monitor with the command serial.begin, and then I will declare my red pin as an output. I have also to create another variable which I generally call status. I don't need to declare any value. And then here status will be equal to digital read of BT, which I forgot to add here. So int BT equals to 13. I have also to declare here BT. So pin mode BT. In this case, it's an input. And status stores the read of BT. And then I will print using the serial monitor, print BT, oh sorry, status. And then let's check if the button is already working. Yeah, every time I click, I can see that it changes to 1 every time I press the button. So now I'll do the condition again. So if status is equals to 1, remember this equal sign is just a comparison. So I'm comparing if status is actually equal to 1. Then in this case, digital write red, and I will say hi. Okay, if I do this, my red LED will be high forever. Doesn't matter if I'm not click anymore, it will stay high forever. Okay, I think some of you had this doubt in the group. Okay, then we have the else condition. The else condition will prevent this from happen. So in case status is not equal to 1, then the LED will be turned off. So digital write red, this case it will be low. So now it should be working properly. If I press the button, then the LED turns on. If I release the button, then it turns off. Okay. We had a question in the group about how to program the LED to be turned on, maybe for a few seconds. We can just use this delay command, and then I can make it turned on for 1 second. For example, if I press the button just once, let's see this happening. So if I press the button, then it stays turned on for 1 second. Okay, we can increase this for 3 seconds, for example. Let me just recompile this. And then 1, 2, 3, and then it turns off. Okay, I think this is the answer for one of your doubts. Okay, now it's time to solve the challenge. Let me delete this, and let's add one more LED here. Let me just change the color of this wire to be red, same color of the LED. And then I'll add a yellow LED. I'll place this LED here. This LED will be yellow. Oh, yellow, it's not a good color. Blue, it's better. Okay. Then one more resistor. Have to take the LED to the left side a little bit. Done. Okay, let's change the value of this resistor, so it will be just 100 ohms. And now I will attach pin 11 to this LED. Let me change the color to be blue. I'll put a light blue so we can see better. And then I have to attach the GND here, and I will change color also, so then you can see better. Okay, so this is the circuit for the other LED. Okay, now what I can do, I have two ways to do this. I can add one more if else block like this. If status is equal to 1, then in this case I want this LED to be turned off. But first I have to declare this LED, which I call blue, and it's equal to 11. Let me also declare here blue. It's an output. Okay. Now, if status is equals to 1, then I will digital write blue, and I will say low. Else digital write blue, and I'll say high. So this should make it work. Let's check. Okay, the LED is turned on, although the button is not pressed. And if I press the button, the red LED should turn on and the blue LED should turn off. Let's see. Yeah, that's okay. So it's working. There's another way to do this with less code. How can I do this with less code? Let me just comment this part so then it won't be compiled. Look, we already have an if-else blocks here. So what I can do here is just say digital write, then blue, low. And here the opposite, digital write, blue, high. So with less code, we can make it work too. So I'm not pressing the button, the LED's turned on. If I press the button, then the red LED will turn on and the blue LED will turn off. Okay, so it's already working. Cool. Any doubts about this? Do you have any questions about this? Hello, Raisa. Hello, Yamusa. Fellow Jitser. Do you have any doubts about this?
So I got it. I don't have any doubts about this.
Thank you. Thank you. Okay. Super cool. So,
Are you hearing me?
yeah, I'm here. I can hear you. Okay. So, now, guys.
Did you hear what I said?
Yes, I did.
I had to repeat.
No, no, you don't need to repeat. Thank you.
It got it.
Okay. Let's go ahead. Today, we'll learn about PWM outputs. Okay, so maybe it's better to reset this environment. Don't worry, it will be recorded so you can watch this video again. So I will just go back to Oakwe. Then I'll add a new Arduino. And first thing, I want you to see this side of the board. Can you see here that we have a warning telling digital PWM till? Okay, this till sign is present in pin number 3, pin number 5, pin number 6, pin number 9, 10, and 11. Okay, so PWM simulates analog outputs. So we can, for example, instead of just turning a LED on or off, we can make it half light, for example, or we can see better. It's hard to explain. Maybe it's better to see these things working. So we have to use PWM pins to have this effect. So let me add a breadboard. Breadboard. And now a LED. LED. A resistor. Let me change the value. 100. Okay, so now I'll choose one of the PWM outputs. In this case, I will choose pin 11. So let's put a wire here. And then I can take a wire directly to the negative leg. Let me just change the color of this wire. I'm sorry about my dogs here. They are a little bit noisy. Okay. Now what we're going to do, let's go there and let's declare the variables. So red, and red is equal to 11. And then here I will say I will start the serial monitor. So serial.begin, and tell the Arduino which pin I'm going to use, which in this case is red, and this pin is an output. Okay, so now I can send an analog command to this LED. For example, here, analog write, and then let me tell you something. This command, analog write, works with values. Works with values from 0 to 255. Okay, this is something that you can never forget. Okay, PWM outputs work with values from 0 to 255. So if I send 0 to this pin, it means I want to completely turn off this LED. And if I send 255, I want this LED completely turned on. Okay, so again, let me explain one more time. 0 means 0 volts. 255 means 3 volts. Okay, which the Arduino pins send when we turn on. Okay, so if I want half light, for example, I can send to my red LED, which is pin 11, something like 127, for example. And then here it's half light. Okay, I can try sending 255. We are using a simulator. Maybe it's not the best place to see a LED changing brightness, but let's check. Let's check if you can see any change. So it's probably a little bit more brighter, okay? So we can see this better if we use loops. So for example, here we are already inside a loop function, but we can have loops inside loops, okay? And these loops that we can code, they have condition. So I will present you for the first time the for loop. So for loop, we have to first initialize a variable which I'll call I. So int I is equal to 0. Then semicolon. Now the condition, while I is smaller than 255, I want to add 1 to the value of the variable I every time this loop repeats. So I can do this, I plus plus. So this I plus plus adds 1 to the variable every time this loop repeats. Okay, just for you to see this happening, I will just use the serial monitor so then we can see this happening. So I will say this, serial dot print ln, and then I'll put the variable I. I'll also put a delay here. It will be to be fast. Okay, so now if I press the button here, we'll see just numbers. Don't worry, the LED will not turn on. But here we can see the numbers. The variable I is going from 0 to 255. And after that, it restarts. Again. After 255, it restarts. Okay? And why it restarts? Because here we have a condition. So while the variable I is smaller than 255, this code will be repeated. When the variable I is not smaller than 255, then we break the loop. Okay? And why it restarts? Because we are in a bigger loop. So this starts again. So this is the idea. Okay? Now I'll send this value to the LED and we'll try to see this happening with the LED. So here I will put analog write red, and then I will put the variable I. So in the first loop, the variable I is equal to 0. Then it goes here. 0 is smaller than 255. Yeah, so add 1 to the variable I. So now it's equal to 1. I add 1 to my LED. Then I come back here and check. 1 is smaller than 255. Yes, it is. So add 1 more. Now I is equal to 2. Then I send 2 to my LED. Go back here and check. 2 is smaller than 255. Yes, it is. Add 1 more. Now it's equal to 3. So it repeats until this condition is not true. Okay? So now let's try to see, as I told you before, we are in a simulator. It's not the best place to see the LED increase in brightness, but let's try to see. So here, it's increasing brightness. I can see here, I'm not sure if you can see, now it restarted. Increasing. and start it back. Okay, we can also make the LED like something like brief. We can use negative values, we can decrease values. So this time I'll make one more for loop. In this case, I'll initialize my variable I to be equal to 255, semicolon, and while my variable I is bigger than 0, I will decrease 1 in my variable every time this loop repeats. Okay, now I'll send this command first to the serial monitor. So serial dot println I. Let's just see. Here we'll see first the value increasing, and when it achieves 255, then it will decrease. 255. Now, whoops, it should be decreasing. Let's check what is happening. 200 while delay. Oh, maybe I need a delay here. Can put 32. Let's see then. Increasing. And then it's decreasing. Okay. Let's just see one more time. Got to 0, then it's increasing. It goes to 255. When it achieves 255, then it will start decreasing. Then when it achieves 1, it will start increasing again. See this? It's happening. So now I can do this to the LED using the analog write function, read, and then I'll pass again my variable I. So let's see. The LED will kind of brief. It increases brightness, and after that it will decrease gradually. Look, now it's decreasing gradually. Decreasing gradually, turns off, and then increases gradually. It's better to do this with a real LED, with a real Arduino, but here we have just a simulator. It's not the best place to see this. So it's increasing. So do you see the importance of using serial monitor, especially when you want to debug something? Maybe you don't know if a sensor or with an output is working, or if it's receiving the values. Every time you want to debug something, you have to use the serial monitor. We have to know how to use it and understand why it's important. Okay, that's why I'm using a lot of times the serial monitor, so then you can see the things happening, not just through the eyes but through the numbers. Okay, I think it's really important. Okay guys, so let me go back here. Do you have any questions about this, about for loop, or about the analog write command. Did you understand that PWM outputs work just from 0 to 255? No doubts, no questions? Okay, this is good. So, guys, I'll send you a challenge during this week, so then you can try to do something at home. Raissa, okay, you are
Yeah, hi,
Brazilian,
Julio.
Raissa.
No, I'm Tanzanian.
Okay, so say I'll try to listen to you. I'm not wearing headphones.
Okay, I was asking about this serial printing. When we're using, let's say, an Arduino IDE, when we're writing the codes, is it important to write this, or we can just go, of course, with the normal codes?
Okay, let me try. Let me check if I have understood. Let me here. Uh, let me share my screen one more time with you, and then I'll open my Arduino IDE. Let me share my screen with you one more time. Can you see my Arduino IDE?
Yeah.
Okay, cool. Okay, every time you want to find the serial monitor here in the Arduino IDE, it's here. It's this magnifying glass here. We have the serial plotter and the serial monitor. So if you click here, you'll see the values down here. Okay, you can activate and deactivate clicking on this icon. Okay, so it really works, and every time you want to debug something, you should use it. Okay, any more doubts? Okay, guys, so I will finish this class. I'll send you a challenge during the week. I hope you have enjoyed this class. See you next week. Goodbye.